Hello, and a very, very warm welcome to this Tata Tiscon e-raise initiative. To understand that better, let's take a quick look at some water statistics. The first one. In the 20th century, the world population tripled. But what happened to the water usage? That multiplied six-fold. What about the availability and use of water per capita? Is the water that is used per person per day, is that equal across the world? We all know it's not. But look at the difference. The US uses almost 600 liters of water per person per day. What about the renewable water? If you look at this picture, we can see how in the red we are, our country. In the red meaning we have almost no annual renewable water left. Of course, there are other countries that are with us, but it's a very happy thought that these countries, especially a continent like Australia, are very, very up ahead in renewing water in every way possible. If we look at the consumption of water over the years in our own country, why are we talking about this? Because we must understand how we have reached this very unenviable state of water usage and distribution. Climate change, global warming, rise in sea level, floods. I'm sure these are terms that we have heard many a time. And yes, these are happening. And yes, these are the reasons why we have such shortage of water. We are suffering with the following problems. What is that? The depleting groundwater level. If we look at this small little graphic, we can see we have a fat extraction and a very slim recharge. What's happening to our fresh water? Diminishing day by day. What about pollution? We are not even conscious of how we pollute groundwater. Here you can see a graphic which shows you the well from where we are extracting water and a septic tank that treats the sewage water so close to the building, to the well, that it percolates and actually sullies the water table. This phenomenon is invisible and extremely, not just invisible, it's also invincible because we can't see it, we can't fight it. And what we are doing is we are polluting our water table. That is completely criminal. What about pollution of surface water? Oil spills, discharge of untreated effluents, discharge of chemicals, medical wastes, all of this contributes to the pollution of surface water. Disturbed water cycle. We all have read in our school what the water cycle is about. The water cycle is about evaporation, is about condensation. Then what happens after condensation is lots and lots of infiltration into the soil. So, reduce. How can we reduce our water usage? I will begin with some of the simple everyday things that everybody can do. And what are these? These are using low flow fixtures. I will talk about the points and then elaborate them in the next few slides. So, use low flow fixtures, retrofit existing fixtures, check for and repair leaks, use fixtures with sensors, learn to close the tap when not in use, that is during showers or washing your mouth and brushing, etc. Use of biotoilets with bacteria and make people pay for consumption of water. Non-revenue water, or as the name for water leakages go, is a vast problem in many cities, and it usually comes from inadequate maintenance of the system. In our country, it is estimated that between 40 to 50% of the supplied water is lost due to leakages in pipes and connections. Not just pipes which are supposed to be maintained by municipalities, but even leakages from fixtures. Now, if we can bring down this wastage, this non-revenue water to 15%, which is the official goal now, then millions of people could have their share of water without need for more water to be produced. Isn't that a most wonderful idea? Close the tap when not in use during daily chores like shower or brushing. Yes, you can turn off your tap, but for your convenience, there are low flow shower heads available which has a simple shut off button. Use of bio-toilets with bacteria. What are bio-toilets? I think if you look at bio-toilets, the concept is not new, but the usage under urban conditions will definitely be new. So in bio-toilets, what we are doing is the first idea is that the urine and the feces must be separated. The urine is taken away separately and the feces are also accumulated separately. Occasionally, a charcoal mixture, that is stone dust, wood chips, etc., has to be added to the feces, which allows for lactofermentation under anaerobic conditions, not aerobic, anaerobic conditions, so that there is the resulting compost really can be used as manure. And urine can be taken away and directly added to compost heaps. So this urine diversion dry toilet is a wonderful way of reducing water usage. I have shown you some models of biotoilets wherein you can see the position of the capsule, the cartridge that will contain the bio waste. And of course, here it is important to have an outlet to let out the gas. The gas can be separately utilized also. So a bio-toilet in practice. This is a two-storied house which shows a waterless toilet. So the waterless toilet is in the ground level, and it shows how the feces will collect here. And what happens to the waste is that much of it goes up into the ventilation system as biogas, and very little solid is left behind. So it takes a long time to fill up. And in here, you can see a foam flush toilet. This I have not elaborated because it is not an established system yet in this country. And then the next point, someone has to pay. We are so used to free water that it does not make sense. When revenue equals expenses, then only water service is sustainable. When expenses exceed revenues, water service, water quality will have to deteriorate and will not be sustainable. What engineers and architects can do? All this time we were talking about what everybody can do. Now let us elaborate on what engineers and architects can do. Check and recommend materials with low embodied water. Second, design with aim of reducing the need for AC by the use of natural ventilation, use of trees, use of static air as insulating material. If air conditioning is essential or unavoidable, for example, in hospitals, in hotels, air cooling systems can be used instead of water-cooled systems for AC plants. The fourth one is push for water audit. Water audit meaning checking how much water we are using for every kind of activity. We tend to have hoses which will let out the water, doesn't matter how much time you keep it on. We can have time nozzles for them. We can have overflow alarms in cooling towers. We can group plants with similar water requirement in the landscape. Now, embodied water. What do we mean by embodied water? Before we come to the definition, let me just join you in acknowledging that the construction industry is very water dependent in every way, in the material, in the different production systems. We need water for concrete, we need water for dust suppression, for cutting, for mortars, plasters, washing. All of that needs a lot of water. And the concept of embodied water is nothing but the virtual water inherent in the materials of construction. What does that mean? That means all the water that goes into the production of that material and then the production first and then the usage. The entire life cycle of a material uses water. So all that water added together is called the embodied water. And we will see why understanding embodied water is extremely, extremely important. Now comes the work of the architect, the use of natural ventilation. Can we design buildings? Can we design complexes where we use natural ventilation to the fullest? Now you're wondering, what does natural ventilation have to do with water saving? Well, it does, because if buildings are utilizing the concepts of cross ventilation by studying the accepted air or breeze directions, then what happens is the use for ACs are going down. With the use of ACs going down, we have less need for water to cool the towers. So therefore, we gain in water. Therefore, we gain in water saving. So we can see here that here is the north line, and if you observe the north line and the accepted wind direction is from the southeast, then we can see how it has been arranged such that the cross ventilation can happen very easily in this way, and the use for air conditioning has gone down. This is an example of a project that we have designed, Mr. Chakraborty and I, but I'm sure this is possible, entirely possible anywhere in our country. I'm sure you do know that trees have a huge role to play in reducing the need of air conditioning as high as 30%. Then we come to use of static air as insulating material. Up until now, air definitely is the most wonderful insulating material. So if we trap air between two leaves, so two walls, the inner wall and the outer wall, then this air will most wonderfully act as an insulating material, not letting in summer, not letting hot air come in, and in winter, not letting cool air come in. So using air has a most wonderful effect on insulation. Again, what is insulation? How is insulation helping us? Insulation is helping us by, of course, reducing the need for air conditioning. I will take this opportunity again to please request you for questions. And I can see there is one question as I'm talking. I can see one question, but I can't read it in fullness. So I will just wait for that to happen. And I will continue the presentation by saying that static air, yes, involves static air as well in roofs. So we can also reduce the amount of heat we are trapping from the environment onto our RCC slab. Air cooling system instead of water cooled, yes, that gives us a lot of water saving by using the makeup water for cooling towers is huge, and that is a wastage. So if we use air cooled chillers, then we have a lot to gain. Reuse. Now, reuse should mean water from sinks and showers to go back to cisterns for flushing. Yes, that means we should be able to use, or rather reuse, water before channelizing water away and throwing it away. We should be able to use it more than once. That is what reuse should mean. And for this, of course, it should be that we wash our hands, and that water can be used for flushing. But reuse also includes concepts like rainwater harvesting. Though really speaking, rainwater harvesting should mean use. It is called reuse or classified under reuse because rainwater falls on a particular surface and then we have to use it from there. So we'll see how that can easily be done. Use bathroom wastewater for car wash and landscape. Reuse of construction site water after settling in vats, as well as reuse makeup water and condensate from AC plant. So yes, the graphic on your screens now is showing how you are doing a hand wash, and the hand wash is actually going into the tank for the cistern. So does it look like it's just a concept, an idea? But no, it is entirely possible to do this. So if you take a section through this reuse tank, we have two parts to it. So one part is where you wash your hand and the water collects. But if you run out of water from hand wash, so there is another part which will always have fresh water. So when you're flushing, you're not waiting to wash your hands. Rainwater harvesting goes back to the Indus Valley times. And during the course of history, we can see that rainwater harvesting has had wonderful examples throughout the country. And we will just look at two states very briefly, very quickly, because Rajasthan is a very dry state, extremely dry, only 120 mm of rain. And on the other extreme, West Bengal is one which has very heavy rain. But Rajasthan has the most wonderful rainwater harvesting, rainwater collection systems that we have ever seen. These tankas or tanks, these were these underground tankas which were really catchment areas for rain. So whatever little rain they got, they saved it. And in these holes, which were really just polished with lime, finished with polished lime to tune to keep it clean. And what about West Bengal? West Bengal had so much water, yet they also had their own systems of rainwater harvesting, and by which they maintained their water balance very well. So what is this rainwater cycle? If I can just briefly show you that. What is this rainwater cycle? See, this is a notional idea, but still, here is the water from the roof, which gets taken by the downtakes, the pipes. It goes into the rainwater tank. Very basic filtration. Why basic filtration? Because the rainwater is actually very pure. The only debris they are collecting is from whatever is there on the roof. So a very minimum filtration is okay with it. And here you collect it and then use it back into the house for various uses, usages. Only one thing has not been explained over here is that because the first rain that comes in a season will tend to, or after a long interval, will tend to carry more debris. We have arranged for a first flush system which takes away that water. But is rainwater only about collection and usage? No. The most important part of rainwater is really recharge. So here is a system of recharge whereby the water from the campus, from the surface, which is definitely dirtier than the roof, will be recharged, will be taken through sand and gravel onto the earth. Now, it is important to allow earth to also do its job. That is, the recharge well should actually not go right down to the aquifer. It should end before the aquifer so that the layers of earth gets the chance to purify the water before it goes to the aquifer. Because endangering the aquifer, the groundwater table, is very, very dangerous. So what we did was, this was a catchment area where we took the water, and here we, because the first flush couldn't really be arranged by the school authorities by turning off the pipe, so we placed two pipes at different heights. So the lower pipe would take away the dirty water and throw it here. The water from the higher level would be taken from here, 90 mm dia pipes, and taken to the tanks. The tanks are actually placed on top of the toilet block. So from the tanks, the pipes would, much thinner pipes, the 12 to 15 dia, would be taken to the toilets and to the drinking water fountain. Yes, even drinking water could be achieved from this rainwater. A very short idea about the quantity. The area of the catchment was quite small, only about 60 square meters. But the yield, if we calculate a runoff coefficient of 0.85 and average annual rainfall of the last few years as 1.68 liters, the yield was about 85680 liters annually. And only during the monsoon months, we can see that the yield is 71900 liters. I have just given a brief idea about the runoff coefficients. Of course, the runoff coefficient is greater when the surface is impervious. So, which the pervious surfaces will be having less runoff coefficient. What about the quantity and how does it match? So, if we are producing 7190 liters in 5 months of monsoon, that translates to 480 liters per day. And what is the need? The need is 400 liters for the toilets and 60 liters for drinking. So 460 into 103 working days in 5 months would lead to 47380 liters, lesser than what we have generated. So if you subtract what we have, how much we need from what we have generated, we get a certain figure. Can we save this? If we can, it is the most wonderful thing to do. But if we cannot, we can at least try to save in as many tanks as possible. So let's say that this school would only invest in 6 number of tanks, only store 3000 liters. Never mind. The rainfall from November to May will be much less. That will be only 13770 liters. So at the end of the year, what do we have? We have 47380 liters from June to October, which is the monsoon month, then 3000 liters saved at the end of the monsoon, and then 13770 liters from November to May, the non-monsoon months. In total, we have generated 64,000 liters of water. Now, if you ask me, is that enough? I will tell you, was this water in your plan at all? So, this water is completely extra with just a little bit of investment. I will just talk about the quality and I will come to the investment part too. The quality, actually, the sulfate, chloride, nitrate was well within the desirable limits. Minerals, of course, minerals was not really there. When they say trace, it means it was not there. But then we don't have to depend on water for our mineral intake, do we? Filtration system for the drinking water was a very, very simple drinking water, which had just a polyamide housing with a 5 micron polypropylene cartridge, and that could generate about 100 liters per hour of water. So if we look at a graphic for rainwater harvesting, then here is the rainwater falling, then it goes right down and through a filter into the sump, through the pump, takes it up to the overhead tank, from where again it goes to the different usages for people. And the overflow from the pump then goes for recharge. So it's a very win-win situation where we are using the water as well as whatever we cannot use, because in the monsoon months, we cannot actually end up using all the water. That will, we can't even use after we store it in the sun. So all that extra water then can be used for recharging the aquifer. And recharging the aquifer is something that we should all aim to do. Dual plumbing. Why are we looking at dual pipe plumbing? Yes, that is important because it should be very clear that one plumbing is being used for recycled water or for rainwater, and the potable water that is coming from municipal supply, we all know that the municipal supply water is potable, drinkable water. So that is entirely separate. So we can use it for the separate purposes. And using two types, two pipes, that is a dual plumbing system, and by using fresh water for the purposes where we absolutely need fresh water, that is for mouthwash or for shower, and using reused water for other purposes such as flushing or for watering plants or for any other, watering plants, car washing, washing the surfaces of campuses. All of this can be used, can use the reused water. So if you have separate plumbing for that, that helps, and that leads in statistically we have seen from records that 1/3 of the fresh water can be saved in this way. Right. Now, dig tank for filling up during rainy season. Now, this is also something that has been a lot of publicity is happening for this, which is that you allow dig a tank, the hapas as we call them locally, dig a tank and allow the rainwater to collect. And then what happens if you allow the rainwater to collect? Then recharge, the most wonderful thing. So the base should be made of materials which will allow the recharge to happen. And whatever collects, that if you allow water to stand for a while, then whatever little impurities they may be will settle down, and you can easily then use the water that is on top. So digging the tanks or the hapas can be of great use. Use of bathroom waste for car wash and landscape. Yes, this is another graphic that shows how this can be done with simple treatment. There is another better graphic which I will show you soon. But here is, a very simple system by which the water from the hand wash is being, after the trap, it is coming down the pipe and being diverted. Here is a valve that diverts the water onto the outside, on the exterior of the building, so that it can be taken to a plant. So you have mulch, the water is coming from here, and it is a direct system by which you are going from basin to landscape. And of course, if there is too much water, or if there is any need to send it to the sewer, then the diverter valve doesn't work. It can also go to the septic or the sewer system of the area, of the particular area in concern. Now, reuse of construction site water after settling in vats. This also is being popularized. Awareness is being brought as to how construction site water has to be reused. So in this side, the same thing, water is being allowed to collect, and this water after initial settlement can be used for a variety of purposes. I think there is a question I saw very briefly. There's a question regarding how construction site water can be reused, but Mr. Chakraborty is answering that question, so I will not go into that, but move on to the reuse of makeup water. So the need for AC, like I said, in hospitals, in hotels, in certain areas, AC is unavoidable. And what can we do under such a situation to reuse? What can we reuse? The condensate, because we are dehumidifying the air in an air conditioning system. What happens is there is a lot of condensation, and what happens to that condensate? It is completely wasted. Now, the concept is to reuse that condensate for the makeup water of the cooling tower. As I'm talking, I'm getting some condensate on my arms, and I'm wondering how did this magic happen? Recycle. So recycle is about treating the grey water and using it for most purposes. And the yuck factor, that is, use of water from sewage treatment plants for flushing and landscaping. But there are areas and people whereby even the STP water has been used for, hold your breath, for drinking. So let us see how that can be done. And in this I will show you, this graphic shows you very, very well how this is being done. So shower water going in for very basic treatment for filtration, and maybe some kind of UV radiation treatment also, that goes into your flush. So you are not worried that your flush is containing some solid water. No. And then after the second usage of water, then it may be either taken away from the site or reusing for landscaping purposes as well. And thank you so much for being a part of this webinar of E-Rays and Tata Tiscon.